Hi, I'm Yuanjia Zhang from Kyoto University. I'm going to present our work, GuideBand. GuideBand is a wearable device to provide intuitive 3D multi-level force guidance upon user's forearm, which produces an effect that the forearm is pulled by a virtual guider or a telepresent helper, and also consider realism in VR. GuideBand uses three motors to pull a wristband. Users can easily follow the directions cues by feeling the pulled wristband. At the same time, can do other actions like operating a VR controller. There are many works discussing about haptic guidance, including skin stretch or vibro-tactile methods. To our knowledge, their guiding direction may be limited, discrete, or with patterns that need to interpret. Sometimes this method would disturb the realism in VR. For force guidance, many works or commercial products provide interactive guidance. While it is not easy to take care of mobility, hands-free design or 3D direction guidance together. So we propose the current GuideBand prototype. The wristband is pulled by the pulling motor via a friction line at different force levels, which generates multi-level stimuli on user's forearm. The pulling motor can move on an arc-shaped track, which provides the pulling direction range from ahead to behind the hand along a horizontal axis. Furthermore, the arc track can rotate around user's forearm that represents a 2D plane. This achieves 3D multi-level guidance. The wristband is combined with a soft Velcro band and several buckles. The band should be worn a bit loose for smooth rotation. The buckles are used for simulating pulled by fingers to achieve clear force perception. We performed a JND study to realize users' distinguishable guiding force levels along three axes. Based on the results, three distinguishable force levels are used to represent different target distances. We then conducted a force guidance study to evaluate the performance of GuideBand and compare it with the state-of-the-art vibro-tactile guidance. Based on a previous work, we used 4 vibro-tactile motors to generate omnidirectional guiding patterns on users' forearm. Participants wore these two guiding devices to find 10 random targets in VR. We recorded the time and accuracy and used a questionnaire to evaluate the experiences in the study. The results show no significant difference on time and accuracy, while we can see participants had better usability satisfaction and spent less cognitive load when using GuideBand. From post-study interview, most participants say they prefer GuideBand, which had intuitive and clear cues. In conditioned vibro-tactile device, participants said they had to pay attention to perceive which motor was vibrating or the guidance patterns. After realizing the performance, we would like to know how users combine with visual and voice guidance in the scenario that users' visual attention focuses on their task and being guided at the same time. The task consists of a main task and a subtask. The main task is a modified Stroop task. The subtask is to follow the guidance to get 6 target objects. 3 conditions were compared in within subject design. The visual guidance is shown in 3 conditions, which is a guidance hand pulling user's forearm toward the target objects. In visual with vibro-tactile or force guidance, the same devices in the previous study were used. The realism and distinguishability of each condition were evaluated in a questionnaire. The results shows the force guidance from GuideBand is significantly realistic and distinguishable than the others. In post-study interview, all participants said they like to use GuideBand. Since GuideBand could provide clear guidance, they relied on force guidance and spent less effort on using peripheral vision to search the targets. In other 2 conditions, especially in vibro-tactile guidance, participants said they had some difficulties to perceive guidance cues well, so they needed to use their peripheral vision to search for and switch between many objects. It was burdensome to them. In conclusion, we propose GuideBand to provide intuitive 3D multi-level force guidance in VR. We conducted 2 studies to tell GuideBand can enhance usability, realism, distinguishability, and decrease their cognitive load comparing to the state-of-the-art guidance method. In future, we hope we can improve the limitation of GuideBand, such as the latency and size problem, to make it become a more useful tool either in VR or a real guidance scenario. Thank you for your attention.